we are going to be doing a binary search, but we're going to turn it into a recursive version. Again, we can test it with our single search tester right now, testing, for example, for 15 in this guy here, and it does find it. But we're going to take a look at this search library. We're going to ignore the sequential search and focus on this binary search. So again, as we recall, how did binary search work? Okay, we start with our low, mid, and high, look in the middle, and continue to update these pointers low, mid, and high because we know it is sorted, getting there again in log n time instead of O of n time for sequential search. Back to our binary search here. So again, we have our low, our high, which is at the very end, and the mid or medium right in the middle. And again, we had as long as low was less than or equal to high, want to keep going, checking if it's there, otherwise updating the pointer. Again, if we are looking and what we're looking for is too big, we slice off the left half by moving that low pointer up and recalculating. Otherwise, we cut off the right hand by moving the high down and recalculating. So our goal, ladies and gentlemen, is to turn this into a recursive version. Now, how would we do that? How would we do that? What would have to change? One thing is if you have binary search calling itself, and this is just calling over and over again, this really cannot be here because then when you called it, you'd be resetting everything back to 0. So we have to get rid of that. This while loop as well really can't be there because we're not looping. We're not looping. Let me get rid of this as well. I'm going to fix my indentation, just Command A, Command I. Okay, so what else has to change? You can modify our signature. In fact, you probably would. How do we do this? How do we get it into a recursive version? Okay, so one thing we have to recognize, how do I update the state of low, mid, and high if I'm not doing it here and kind of cycling through a while loop? The key is, just like our other practice problems, we pass in the state through these parameters. We're going to pass in the state of the low, the mid, and the high through the parameters, right? How to change or update the state, right? We pass in through the parameters. Okay, now I can put low, mid, and high here, or notice that medium is always just calculated based off of low and high, so I can just do low and high here. So now, again, I could pass this updating state. Initially it starts at 0 and the end, but then I can just keep updating them as I go here. All right, so I'm just going to delete this. What I can do is, again, just recalculate medium by doing this. Now, next thing to calculate is how do I do this recursively? How do I get this to call itself? Which means, again, we need a base case, we need a recursive call. Let's think about what would our base case or base cases be? Well, just think about if I'm searching for something in a list, if I'm looking for something, looking for a number, the possibilities are I either find that thing or I don't find that thing, right? So I'm going to keep this just for a second, but our first base case is really if I searched and I found that thing, boom, that's a base case. Another base case, so it's either found or not found. So if I found it, great, return that guy. If it's not found, so if it's not found, I want to say I didn't find it. And remember, how do I do that? How do I signal I didn't find it? That is, I'm going to return -1. So I'm just going to cut that and paste it here. Now, under what condition is that? So remember, we kept looping. As long as low was less than or equal to high, there's a chance it was there, right? As long as low is less than or equal to high, it might be there, keep searching. So if I flip that around, again, a signal that it's not there is if low crosses over and is greater than high, we know it is not there. Okay, so those can be our two base cases. I found it or I didn't find it. Otherwise, we can come in here and perform kind of the same idea here. We say, hey, you know what? I can replace this with a return binary search of, again, passing the same thing, num, list, and then low and high, low and high. What would be my new low? It would be, because I'm slicing off the left half, medium +1, and the high stays the same, stays as high. Okay, so I move the low up, and again, when I call this, I'm going to recalculate mid based off of that new low and high, so I move this guy up. Same thing here. If I want to cut off the right half, I'm going to return binary search of num, list. This time, I want to cut off the right half. So low stays the same, low stays the same, and I'm going to bring high down. So high is going to equal medium -1, just like we have right here, right? We're just updating high. So I can cut these guys now. So again, we're going to keep cycling, not through looping, but by just calling different versions of binary search, passing the state of these parameters, again, continually updating by cutting off the left or the right until I either hit this guy or this guy as our base case. Now, this is great. I can save it and it compiles, but if we look over here at our tester, wait a second, what's going on? What is the problem? Oh, the problem is now we broke the code of the person calling this. And so if somebody's relying on your binary search, they're going to be kind of ticked off at you, right? Because you promised through like your API, binary search requires two things, what you're looking for and where you're, the array you're searching in. You've changed that contract to now require 4 things or 5 things. So instead of angering the people that are using our code, we want to keep this as a black box. We don't want to disturb their code. Come back up here, and instead we're going to create a wrapper method, right? Something that somebody can call. Okay, so what I can do is turn this into a private method, so it's like a black box, and this will be public static int binary search, and we keep it as just 2 parameters, int num, int array list. So that way the outside world can just call this guy, and then internally I'm going to call this private recursive version. Okay, and so what is this guy going to do? It's basically going to call this guy with the initial parameters, right? We're going to call the recursive method with the initial parameters. So if I look, I want to call binary search, and I want it to return this int, right? Because I need that to return back. So I'm going to return binary search, and again, Java differentiates between the 2 parameter and the 4 parameter version. We can overload that. So num list, and what is my initial low? Well, the initial low again is that 0 element. Initial high is the length minus 1. So low is 0, and the high is list.length minus 1. And so there we go. If we save that, now the outside world is like, oh, okay, cool. It's still working. Again, internally, I call this, and then I call this private version. It does this recursive thing and returns back either -1 or what the index was. And so let's just test this out to make sure that it still works. Again, it's always good to try a variety of tests. Search for 15, still there at index 3. Yep, let's try something else, like something in the front, like 2. Found the 2. Great, let's try something that's not there in the front, like -5. Let's see if that works. -5. Couldn't find it. Great. And you know what I should do, actually? Let me go ahead and just pop a system out here, just so we can see it after I calculate the mid, just so we can see it. All right, let me try another one here. Boom. All right, so we can see again how these pointers update. Again, not with the iteration, but with the recursion. So -5 doesn't work. Let's try something on this end, like 85. 85, searching for 85. Can we find it? Yes, we can. We found it at index 13. Again, we can see those pointers update. Let's try something that's not there, like 87. 87. Okay, and again, we keep going until low crosses over high, and we couldn't find it. Fantastic. How about 94, right on the edge there? Okay, and again, we found it right at the edge. So again, you can test that with a variety of cases, but overall, again, our binary search recursive works in a very similar fashion, except using recursion.